Thank you so much. So my name is Sabrina. I'm here with my colleagues, Aileen and Maya. And our Globe Ireland team is hosting this special webinar for Tree Day. So it's a day to celebrate trees, nature, and the earth, today and every day of the year. Our program is called Globe. It's an international citizen science program, and it's sponsored by NASA. This is one of the reasons we have Brian with us today. He works at NASA. And in Ireland, it's supported by the Environmental Protection Agency. So with Globe, you can become nature explorers and supporters. We explore everything from plants and soil to water and air. And I want to say a special mention to the 30 classes involved in the Colorful project who are currently monitoring leaf color change on their favorite trees. Thanks so much for your help. So we're lucky to have two amazing guests today, Brian and Mary. They have some brilliant stories and facts to share with us. So to start, I'm going to chat with Brian. Hi, Brian.
Hi, Sabrina. Thank you for the invitation and happy Tree Day to everyone in Ireland.
Thank you so much. Thank you. So Brian works at NASA. He's an Earth Science Educator. So Brian, I was always curious to know, what is it like to work at NASA? And do you get to see some cool satellites and rockets in your place of work?
Yeah, so thank you for that question because I've been at NASA 23 years now. And it's an amazing place to work. It's extremely busy because NASA, as you know, most people think NASA, they think of, space shuttles and astronauts and, people going to space and looking at the moon and all those places. But we actually do a lot more than just stuff in space. We look at our planet. We really look at Earth. NASA has the largest group of Earth scientists, basically people who study the Earth in the world. And
Wow.
where I work at the NASA Wallace Flight Facility in Virginia, it's part of what's called the Goddard Space Flight Center, one of the major NASA bases, and that's actually in Maryland near Washington, D.C., our country's capital. And they have literally a couple thousand Earth scientists at NASA Goddard Space Flight Center. And yeah, I want to share with you something. If I could just share my screen, Sabrina, a
Yeah,
couple
please do.
really couple cool images because I work with satellites, and as I'm talking, I'll share my screen. I work with satellites all the time. I've been working with different satellites, basically called Earth observing satellites, and these satellites really, really, really highlight some of the things we can see from space on Earth that just walking around the planet in your local environment, you can't really see. Okay, even though it's important to observe your environment, we see things from a global perspective. And Sabrina, does that look good on your end? Can you
Yeah,
see
it
this
looks
here?
good. I assume that's Ireland. We don't see it
That
all,
is,
but we see yeah, we see a good
yep,
chunk of it.
yep, that is Ireland. And I have a larger a picture of this where you can see all of it. But I wanted to show you this because, when we think of Ireland, especially in the United States, we think of, the country being completely green. And this happened to be a rare day several years ago where there was zero cloud cover over Ireland. So
Mm-hmm.
we see the entire country. It was pretty awesome stuff. So off to your question again, Sabrina, is that, do I get to see cool rockets and things like that and satellites? And yeah, I work at the Wallops Flight Facility. We have Wallops Island, and it's a launch facility there where some of our major launches are ones that get sent to the International Space Station to resupply the space station with food and clothes and experiments for the astronauts to do on board. But the satellites that I mentioned earlier are really cool because they have to get launched into space. And one of the satellites I work on is called the Ice Cloud and Land Elevation Satellite, or IceSat-2. And I'm going to show you this quick video. I was at the launch of this satellite, this rocket, where the satellite is in the nose cone about 5 years ago in California, where we launched it. And you can see here, and this is actually one that I recorded with my cell phone. I was doing what's called a Facebook Live at this launch.
Oh
This was
yeah.
at 6:02 in the morning, but you'll see how thick the cloud cover is. Well, let me just show you this, and it just shows you how bright these satellite launches are, these rocket launches. Let me show you this here.
Whoa! Yeah. Whoa!
See,
Oh, wow. How far were you from the launch there?
that was probably I'm gonna say maybe 5 kilometers away. So it was kind of
Incredible.
close as we could be because of if anything would happen to the rocket. And you can see here, this is
Mhm.
actually a close-up shot of the rock of ISAT-2 launching. This is where they have cameras set up to manually take pictures. Sorry, to automatically take pictures of the rocket launch. So this is what it
Okay.
was close up. But this is the
Woo!
type of cool stuff that we do at NASA for sure.
Yeah.
And there's the full picture of Ireland.
Our beautiful country. As you
Yes, and
said,
these,
it's
and
so
yes,
green.
and when I work at NASA, this is the type of stuff that we look at. We can tell a lot of things by this image. We can see how green the country is. We can see areas where there's not as much green, where there could be mountains or hills. We can
Hmm.
look at oceans around it to see how deep or shallow, if there is algae. We can see the cloud coverage off to the west. So we can see
Okay.
lots in here.
Okay. So yeah, satellites can see a lot indeed. But we have students as part of Globe who are doing observations as well of their local environment.
Mhm.
What's the value of that then?
So yeah, so satellites can see a lot from space. For instance, okay, we have satellites like this. I mean, this is, and I should mention, these satellites don't crash into one another ever because we have it precisely programmed that they don't. But all these satellites are flying through space super fast,
Hmm.
over, I'm going to say like 10, 11,000 kilometers an hour. They're super fast. But even though satellites can see a lot, they can't see everything. And that's why we need observations from the ground, because the satellites are up in space looking down at Earth. But you, as students and citizen scientists and the teachers there, we really need that data from the ground looking up, because the satellite can't see, the details in your local environment,
Hmm.
very closely. It's not able to see the individual, branches or leaves or, the tree trunk. We can't really see that, but those type of measurements of a tree are super valuable because they allow us to understand, how a tree goes through photosynthesis, how a tree stores carbon, how it eliminates carbon from the atmosphere based upon what the tree looks like, what it's like. Satellites aren't looking to see what the tree looks like, and they're not identifying tree species, or they're not
Hmm.
identifying how fast the leaves are coming off, things like that. But that's where the ground-based observations are super important, and these are just some examples of some of the satellites, and I'll just go through here. And this is one of my favorite things here. Is this is an example of what satellites see. Okay, these
Okay.
are the space-based observations. You can see here, everything from the sea surface, the blue marble showing you the green here, and then biosphere, that's showing you all living things on the planet. And then we
Okay.
have things like soil moisture as well.
Hmm.
But this is where your question is super important, because there are over 3 trillion trees on the planet, and the satellites will never ever be able to take measurements of all 3 trillion trees, because there's lots of variables that happen, whether there's clouds in space which are blocking, some of the sensors that see the trees. We need those ground-based measurements as well. So as you can see, this is showcasing 3 trillion trees on Earth and over 78,000 tree species. And like I said, the satellites can't identify what tree species they are. That's where, all of you come in to help
Hmm.
identify tree species.
Okay. So yeah, so human
Yep.
observations and observations from the ground give much more detail, and I guess let us understand what's going on as well, which is really important. We don't want
Yeah.
just satellites
Yeah.
to get the big picture. We want to understand what our local environments are, what's going on there, and how can we help. It's a big part of Globe as well.
Yeah.
I was just curious as well, because I know you're the lead for tree observations and many more things at NASA. And I was wondering, for the scientists at NASA, what are the big questions about trees and vegetation at the moment? What are they trying to figure out?
So yeah, so I love that question because I could go on for days on that question, but to shorten it a little bit is that
Yeah.
scientists really look at trees in the sense of being an indicator of a changing climate or climate change or global warming because trees, as you know, help us breathe through a process called photosynthesis.
Mhm.
Photosynthesis is when trees are pulling carbon dioxide out of the atmosphere, that nasty stuff that we breathe. We don't want to breathe all carbon dioxide because it's bad for us. We get a lot of that from cars and factories and people in general, in populated areas. But trees, through photosynthesis, pull carbon dioxide out of the atmosphere. And they do this all the time, all the time, around the world. But scientists are trying to figure out our global carbon budget. And what that means is how much is the balance between how much carbon is in our atmosphere, versus how much gets pulled out by trees and vegetation and grasses. So you can see here, this is what I like to call the lungs of the earth. And this is showing you leaf area index. This is showing you leaves and trees that are going to green up, green down, green up, green down, and with the seasons. So this is a really, really fun thing to look at. But, we have, you know, you are focusing a lot right now. Well, I'm in the Northern Hemisphere as well. So we're focusing on green down right now. So green down is super important because when we look at deciduous trees, like the oak trees or the maple trees, or even like lime trees as well, you know, when they start losing their leaves, they're basically, you know, losing some of their energy. They spend less energy through the winter, and then photosynthesis sometimes completely, stops in some areas where it's super cold. There's no leaves on the tree, things like that. But they slow down.
Mhm.
That means photosynthesis slows down as well. But they are still working to help our environment. And I want you to watch this video here. This is a new one that NASA just put out. And you'll be able to see, I want you to look at the dates here. Okay, and look, where Ireland is here on the map.
Okay.
Okay, you can see, and what you're going to see here is you're going to see these really bright orange colors. And this is where there's lots of carbon dioxide. But you're going
Wow.
to see there's going to be a relationship between when you see all this orange and the limited green you see, but as it starts getting greener, like what's called green up in the spring and summer in the Northern Hemisphere, you're going to see a decrease in this carbon
Okay.
dioxide. Trees are pulling this out. As you can see right now, we're in summertime
Uh-huh.
on this, and there's less carbon because the trees they've greened up. Okay, they're not that green down yet, but you'll see here in the fall, kind of coming to where we are right now, you're going to see the trees are going to start to green down. And then when you see these greening down, you're going to see the carbon dioxide building up again.
Yeah, you see it very visible in the Northern Hemisphere. It's, oh my goodness.
Yeah, the photosynthesis is slowing down. Okay. Now, I don't want anybody to be scared about this because we don't actually see this orange vapor in the sky. It doesn't look like
Uh-huh.
this. This is just what's called visualization. It's showing you, if we just have it, the carbon dioxide is basically invisible. But if
Yeah.
we want to look at it on a map like this, we have to give it some type of color to see. And you can really see here in the wintertime how thick the carbon dioxide is when a lot of the
Mhm.
trees have greened down, they lost their leaves and are not going through a lot of photosynthesis. But
Okay, the
here,
difference is mesmerizing. Yeah, it's
yeah,
incredible.
and then you'll see now we're getting back to like green up, and you're going to see that, starting to decrease as the plants in the Northern Hemisphere, the trees in the Northern Hemisphere are getting their leaves again. You're going to see it opening up again little by
You
little.
see a delay, like
Yeah.
yeah, they put up their leaves, I suppose, in April, May, but you see the decrease in CO2 really happening in summer because they probably are
Yeah.
photosynthesizing more.
And that's
But
why
then, yeah.
the green down and green up data, especially the green down data, is super important because we're seeing those times when trees in the Northern Hemisphere, like in Ireland, are greening down kind of further into the fall, later into the fall, and even into sometimes into the winter, because we're seeing a shift in our climate. So things are often staying warmer for longer periods of time. Therefore,
Yeah.
your observations on the ground of when leaves are falling down, when they're falling off of trees, it's super important because scientists need to know when that's happening. And
Yeah.
it seems to be changing every year.
Yeah, it's changing, and we know, I mean, with climate change, things are shifting too. So, yeah,
Yeah.
your observations matter a lot. Thanks so much, Brian, for all of this.